Okay, hi guys, let's take one more problem on partial fractions. Okay, so this type of sums which I will be taking now are bound to come in exams, so please pay attention. Okay, so let's say if I want to find Laplace inverse of s square plus 2s plus 3 upon s square plus 2s plus 5 upon s square plus 2s plus 2. Okay. So how will I understand that this problem is based on partial fractions? So seeing at the question, you should understand that. So this is multiplication, the denominator involves multiplication of two quadratic terms. Okay. So quadratic terms. So you should understand that. Yes, you have to use partial fractions to solve this. So what I do is, first, see, all the three terms, that is one in the numerator and two terms in the denominator, are in quadratic form. So first I'll have to make it perfect square. So sums like this you'll have to make first perfect square. So how do I write? I'll write this as Laplace inverse of, now to make this as perfect square, see, I have s square plus 2s. Okay, so what do I need? A plus b the whole square is what? A square plus 2ab plus b square. So I have s square plus 2s. So 2s will be what? Nothing but s square. So a will be what? S, right? So I want b. So this is nothing but 2s. So this will be nothing but 1. Okay? So b square will be 1. 1 square, which is nothing but 1. So I want 1. So I can take that 1 from 3. Okay? So s square plus 2s plus 3. Right? I want 1 from 3. So I'll write 3. I'll write 3 as 1 plus 2. Okay? Similarly, same thing, s square plus 2s plus 5. I want 1, so I'll take that 1 from 5. So s square plus 2s plus 1 plus 4, which is nothing but s square plus 2s plus 5. Right? Same thing here. So this will be what? S square plus 2s plus 2, right? So 1 plus 1 is 2. So I can write this as Laplace inverse of s plus 1 the whole square plus 2, right? So this becomes what? S plus 1 the whole square, right? S square plus 2s plus 1 plus this 2, and similarly the denominator becomes, so this becomes s plus 1 the whole square, s plus 1 the whole square. So I'm left with what? S plus 1 the whole square plus 4, right? Plus this 4. So 4 also I can write as 2 square, right? And similarly this term s plus 1 the whole square, right? Plus 1. 1 also I can write as 1 square. So we'll express this, if you have quadratic, we'll express first in terms of perfect square. Perfect square as in, we'll make each term perfect square. So s plus 1 the whole square plus 3 you will write as 1 plus 2. So this becomes s plus 1 the whole square plus 2. Similarly, s square plus 2s plus 5 becomes s plus 1 the whole square plus 2 square. And s square plus 2s plus 2 becomes s plus 1 the whole square plus 1 square. So if you'll observe now, this is what s plus 1, numerator has s plus 1, as well as two terms in the denominator also have s plus 1. So we can use shifting property, right? So this will be what? According to shifting property, we have plus 1. So we will have e raised to minus t, right? Plus 1. So that will be what? What we had shifting property, Laplace inverse of phi of s plus a was what? E raised to minus at f of t, right? This was shifting property. So I have what? S plus a. So s plus 1. So a is what? A is what? 1, right? So e raised to minus at. So this becomes e raised to minus t. Okay. So after using shifting property, what we do? We replace all s plus 1s. all s plus 1s by s, right? According to shifting property. So what this becomes? E raised to minus t into Laplace inverse of s, but s plus 1 now becomes s plus 1 becomes s, right? After applying shifting property. So e raised to minus t Laplace inverse of s square plus 2 upon s square plus 2 square upon s square plus 1 square. Okay. What I did? I applied shifting property. So you can write that by shifting property. Okay. So what we have is e raised to minus t into Laplace inverse of s square plus 2 upon s square plus 2 square into s square plus 1 square. Okay. So now if you'll see, we have all s squares, and usually in the previous problems we all had terms in s. So now it is s square. So to make it simpler, what I do is I replace this s square by, let's say, x. Okay. To make this simpler, I just replaced s square by x. So what this becomes? Is this Laplace inverse of s square plus 2s plus 3 upon s square plus 2s plus 5 into s square plus 2s plus 2 becomes what? I'm just replacing s square by x. Okay, here s square by x. So this becomes e raised to minus t into Laplace inverse of x plus 2 upon x square, x plus 2 upon, I am replacing s square by x. So this becomes x plus 2 upon s square is nothing but x. S square is nothing but x. So x plus 4 into x plus 1. 2 square is 4. 1 square is 1. So what I did? I just replaced s square by x. So the sum becomes simpler. So s square plus 2 becomes x plus 2. S square plus 2 square, this is nothing but s square plus 4 becomes x plus 4. And s square plus 1 becomes x plus 1. Okay. Now what we do is, now we can apply partial fractions. Okay. So in order to do this, what we did was this. Okay. So this type of sums can come in exams. Okay. So now we'll apply partial fractions. So what we have now, you can write, consider x plus 2 upon x plus 4 into x plus 1. So all are linear terms, right? So what I do is, I write this as a upon x plus 4 plus b upon x plus 1. Okay. What I did? A upon x plus 4 plus b upon x plus 1. So what this will be? A into x plus 1 plus b into x plus 4 upon x plus 4 into x plus 1. X plus 2 upon x plus 4 into x plus 1, right? So denominators are again equal, so we can equate the numerators. I'm writing it here. So what do I have? I can write now x plus 2 will be equal to what? A into x plus 1 plus b into x plus 4, right? Since the denominators were equal, so I just equated the numerators. Okay. So if I put x as, let's say, minus 1. If I put x as minus 1, so this will be minus 1 plus 1 will be 0. So this will be 0. Minus 1 plus 4 will be 3. So what I have is, and this will be 2 minus 1, 1. So what I'll have is 1 equal to 3b. So what this will give me? B equal to 1 by 3. Okay. So this is the way to solve. And suppose if I put now x equal to minus 4. So if I put x equal to minus 4, so minus 4 plus 4 becomes 0. So this term goes off. I am putting x as minus 4. So minus 4 plus 1 is nothing but minus 3. And minus 4 plus 2 is nothing but minus 2 is equal to what? I have minus 4 plus 1, right? So minus 4 plus 1 is nothing but minus 3a. So this will give me what? A as 2 by 3. Right? So I got the values of a and b. A as 2 by 3 and b as 1 by 3. So what I'll do is I'll substitute these values here. Okay? Equation 1. So what I have is x plus 2 upon x plus 4 into x plus 1 will be equal to a upon x plus 4. A I have is 2 by 3. So 2 by 3 into 1 upon x plus 4. B I have is what? 1 by 3 plus 1 by 3 into 1 upon x plus 1. Okay. So what I did? I found out a and b and I substituted in equation 1. Okay. So this will be this. Ultimately we got this. So what I have now? I have Laplace inverse of this, that is s square plus 2s plus 3 upon s square plus 2s plus 5 into s square plus 2s plus 1 is nothing but e raised to minus t into Laplace inverse of what? 2 by 3 into Laplace inverse of 2 by 3. See, Laplace inverse of this, right? Laplace inverse of this x plus 2 upon x plus 4 into x plus 1. But we solved this according to partial fractions and we got this. So that will be what? Laplace inverse of 2 by 3 into 1 upon x plus 4 plus Laplace inverse of 1 by 3 into 1 upon x plus 1. Okay. So what I did? I found the values of a and b using partial fractions and I just substituted this here. So this will be what? But our x is what? Our x is s square. So resubstitute it. So this will be what? E raised to minus 3 into Laplace inverse of 2 by 3 into 1 upon s square plus 4, right? X is s square. So I am resubstituting x with s square. So 1 upon s square plus 4, okay? Plus Laplace inverse of 1 by 3 into 1 upon s square plus 1. So now we have what is standard form, right? 1 upon s square plus 4, 1 upon s square plus 4. Okay, standard form. Similarly, 1 upon s square plus 1, standard form again, 1 upon s square plus 1. So what I have is e raised to minus t into 2 by 3. This is nothing but 1 upon s square plus 4. So 1 upon s square plus 4. So that is what? 1 upon a sin at. So a value is what? S square plus 4. So that is nothing but 2 square. So value of a is 2. Okay. Value of a is 2 for the first term. Similarly, value of a is 1 for the second term. The first term, value of a is 1 for the second term. So this will be what? 1 by a, right? 1 by a sin of 80. So 1 by a, writing here, 1 by a. So 1 by 2, 1 by 2 sin of 80. A is what? 2. So sin 2t plus 1 by 3, 1 by 3 into 1 upon s square plus 1. So 1 upon a sin 80. So 1, okay. So sin t, right? So this is what? This 2 and this 2 goes off. So e raised to minus t upon, so this becomes 1 by 3 and this also 1 by 3. So I can take that as common. And I'm left with a sin 2t plus sin 2, right? This is nothing but my final answer. Okay. So what we did, we had the question in this form. So we understood this is nothing but partial fractions. By partial fractions, both the numerator as well as denominator had quadratic terms. So first step in such sums is what? First step is to break the question in such a way that each term represents a perfect square. Okay. Each term represents a perfect square. So what I did to make it perfect square, I took 1 from this, right? A square plus 2ab plus b square. So we had this, we needed 1. So we took 1 from the constants. Okay, we made this as perfect square. So after that we applied shifting property. According to shifting property, we got this. After this, to make the sum easier, we just replaced s square with x. After replacing s square with x, we have this. Then we solved this by using partial fractions. We got the value of a and b, right? After obtaining the value of a and b, we resubstituted here, and then again we resubstituted value of x as s square, x we replaced with x square, x we replaced with s square, and then this came down to standard form, which was nothing but this.